on this first one, we are doing find the area between two curves, so I set the equations equal to each other, so x squared equals 4x minus x squared. Set them equal to 0, so we get 2x squared minus 4x equals 0. Factor out of 2x, I get left with x minus 2. So x equals 0 and x equals 2. So plug a number in between to test which one's on top. So I pick 1, that'd be 1. Pick 1, 4 minus 1 is 3. So this, oh geez, sorry about that. So this one is on top. Or I could graph it and I can see that that's a negative x squared, so it's going to look like this. And this one's a positive x squared, so it's going to look like this. So they intersect at these 2 points, 0 and at 2. Okay, now I take the top function, which is this one, and I minus the other one. So I'm going to take 4x minus x squared, and I want to subtract this second function. So distribute the negative if you need to here. I don't really need to. So I get a negative 2x squared. And that's what I'm going to integrate from 0 to 2. And so I'm going to take the power rule. So that'd be 2x squared minus 2/3 x cubed from 0 to 2. So I plug in 2. I plug in 0, and I'm going to subtract that. So I'm going to subtract. And again, with this one, I really don't need to put in and subtract, so that becomes positive. I really don't need to plug in 0. So I really just get plugging that in, I just get 8/3. So we get 8 minus 16/3. Right? So I get 8/3 in the end. So simplifying all that, I do get 8/3 in the end. Okay. Next part, same thing. Again, if I don't know which one is on top, right, this x squared, so it looks like this. This square root, so it looks like this. So they intersect here and here. So that means this one's on top. But if I don't know that, I can set them equal to each other. So square root of x is just x to the 1/2 equals x squared. Set it equal to 0. So then I can factor out an x to the 1/2 if I wanted to. And then I would get that x to the 3/2 minus 1 equals 0. So then I get set this equal to 0, set this equal to 0. So I get 1. I can raise it to the 1/2 power, or raise it squared. Square this. I get x equals 0 is the solution. I want to raise this to the 2/3 power. I'm going to raise this to the 2/3 power, so I get x equals 1. So I get 0 and I get 1. So there's my a and b. I can pick a number in between and plug it in here and see what I get. So I can pick 1/2. Square root of 1/2 is, I don't know, but it is bigger than 1/4. Okay, so there you go. Now I can integrate this. It is top minus bottom, so it is x to the 1/2 minus x squared from 0 to 1. So I integrate that. That's 1/2. So I get what, 3/2. So I get 2/3 x to the 3/2 minus 1/3 x to the 3rd power, and I'm going to take that from 0 to 1. So again, plugging in 0 is not going to matter, so I'm really just plugging in 1. So I'm going to take 2/3 and I'm going to subtract 1/3, and I get 1/3. So there's that one. Next one is asking for washer method, or yeah, this one is asking for a washer method. Find the shape created by this, so y equals 2x about the x-axis. So whenever I'm spinning about a horizontal axis, like this one, x-axis, then I really want, if I'm doing either solids or washers, then I want it perpendicular cross section. So that means I want my equations to be y equals. So if they're not y equals, sometimes like if this one, I would have to go ahead and solve it. So for instance, if I had the equation x equals y over 2, and my second equation was this, I would just go ahead and multiply this one by 2, and then they're both y equals equations, right? Because if I'm horizontal line of rotation, I want a perpendicular one for solids and washers, okay? Or for disk and washers. All right, so that's what I would want, and they both are y equals, so you might have different ones. You might have to set them equal to y, or vice versa. If I have a vertical line of rotation, I want my equations to be x equals, so if they're not x equals, then I want to solve them for x, okay? All right, erase all this. All right, back in. All right, so I have 2x. Again, I would want to set these equations equal to each other because they don't give me an a and a b. So I'm going to set these equations equal to each other. Solve for x. So I'll factor out an x. So I get x equals 0 and x equals 2, right? So those will be my a and b. Sometimes those are put into your list of, you might solve from your homework. Sometimes those put on the list, x equals or x equals a number or y equals a number. So that's usually your a and b. So there's my a and b. And then I need to know 2x looks like this, right? And an x squared would look like this. So they intersect right here and right here at 0 and at 2, right? And then I'm spinning this about the x-axis. So I'm taking this and spinning that, rotating it about. So it creates a washer. So I want my cross section would be right here, and that would be a circle. So I'm going to use this formula with my radius squared, right? And then so I need my radius. My radius is the radius of the cross section, but because I have a washer, it's a little bit different than this one. It's the same thing except for I have my top function. So the top function, its radius squared minus the bottom radius squared. Okay, and then still 2 pi out front and still dx at the end. Okay, so my top function would be this 2x. So the distance from here to the top would be 2x. So that'd be the radius of the top function. Squared that, so that'd be 4x squared. Then the bottom one would be from here to the bottom function, which is just the bottom equation, right? So it's always from the line of rotation up, okay, if you're doing it horizontal line of rotation. So that would be minus the bottom function, which is x squared, and that's squared, because I got to square my radiuses. So that'd be x to the 4th, and I'm going to integrate that. Pi out front, my a and my b, so 0 and 2, dx to the n. Okay, so now I'm just going to take my integral of this, so that would be 4/3 x cubed minus 1/5 x to the 5th from 0 to 2, pi out front. So I'm going to plug in 2. This time I don't have to plug in on 0 because that both has x in it, so I don't have to worry about that. So I'm going to go ahead and plug in. I'm going to plug into, I don't have to worry about plugging in 0, but I'll go ahead and just put it in there just so you remember. As long as there's an x in each one, you really don't have to worry about it. But if you only have one x, then you do have to worry about it. And I think we have an example like that. Okay, and then there's pi out front. So you plug these in, and you get like 32/3 minus 32/5. Not 32/5. Yeah, you do. The pi out front. So that reduces down to 64/15 common denominator. So there's your final answer for that. Yay. All right, next problem. Look at this. All right. Okay, so we're doing this method again, shape through rotating about the x-axis again. So I want my equations to be y equals, but I notice that I only have 2 equations that says y equals 0. So I just, again, set them equal to each other because I have no, like, if your equations are y equals, you should have, like, x equals a number for your a and your b, but since I don't, that means I need to set these equations equal to each other. So sometimes your homework left one, it would say, like, x equals 0 or x equals 0, and you have to find the other one, right? Or x equals 3 or something like that, and you have to find the other one. So set them equal to each other. So 2 minus 3x squared equals 0. So we get, let's see, if I subtract 2, divide by -3, I get 2/3 x squared, square root, we get plus or minus the square root of 2/3. Oh, that's gross. Okay, so here's my graph. The -2 minus 3x squared would look something like this, right? And it would intersect at 0. So I have this boundary here. So I'm really rotating this. Well, what's kind of nice about this one, I go from negative root 2/3 to positive root 2/3. So really, I could just take half of it and then just times it by 2. So I'm just going to take half of that and then times it by 2. And so I'm just going to go from 0 to square root 2/3, which is a little bit easier to deal with. And then it's going to be perpendicular about the line of rotation. So there's my line of rotation. So it's going to be perpendicular cross section. Okay, and that's just the equation from here to here, right? That distance, that radius. So that's just my equation. So 2 minus 3x squared, square that, because it's always radius squared when you're dealing with cross sections that are circles. So FOIL that out. We get 4 minus what? 12x squared plus 9x to the 4th. Okay. All right, and then now we have to take the integral of that, right? Okay, running out of room here, and that kind of stinks. So then we take the power rule. So that would be what? 2x squared minus 4x cubed, and then plus 9/5 x to the 5th. Ugh. From 0 to root 2/3. Ugh. And times that by 2 pi. So this time, if I plug in 0, I'm good. I don't have to plug in 0, right? But I'm going to plug in root 2/3, which is not great. So that is not very fantastic. So let me go ahead and do that on a calculator. Quick correction here. This wouldn't be 2x squared, would it? So you're probably guessing that should just be 4x, right? Just the power rule on that one. Okay, sorry about that. Okay, all in my calculator. That comes out to be 10.94 approximately. So that's what it comes out to be. All right, yeah, fun. Huh. Okay, so then we have this one about the y-axis. Now I'm rotating about the y-axis. So that means I would normally want my line to be perpendicular. So that means I would like x equals equation, but I noticed that I got a y equals equation. So then I would probably want to do cylindrical shells because then my cross sections would be perpendicular to the line of rotation, which this does say use cylindrical shells. So then sometimes you'd have to manipulate that, say, use cylindrical shells and it's a vertical line of rotation. You'd want to maybe manipulate this until you get y equals. So sometimes you have to rewrite those equations based on your line of rotation and what you're trying to do. All right, so this equation again, we just have look something like, again, a quadratic, right? And about the y-axis there. So we get something that maybe looks like this. Okay, so we can graph that, check it out. We can set this equal to 0. So factor out x, 2x minus 3, 2 minus 3x equals 0. So that means x equals 0. And what would that be? 2/3 again? 2/3. and x equals 0. So those two, so this would be at 2/3, and this would be at 0. All right, and then we're rotating about the y-axis, so we want cross sections with cylinders. So then my radius here is just going to be from the line of rotation to my cross section, right? So for this particular problem, it's just x. All right, so sometimes that may change depending on where your line of rotation is, but it's from your line of rotation to your cross section. Okay, so my radius here, I'm going to use the formula for cylindrical shells, which is 2 pi times for your A and your B, which ours is 2/3 to 0 or 0 to 2/3. The radius times the height, so the radius is from the line of rotation to the cross section, which ours is x, and then the shell height, right, which ours is from the x-axis up, which is our equation in terms of y, or in terms of x. So in terms of x here. In terms of x means y equals. Okay. All right. So then we go ahead and distribute that. We get 2x squared minus 3x cubed. We're going to integrate that from 0 to 2/3 with a 2 pi out front. That's cylindrical shells. So now we do the power rule. We get 2/3 x cubed minus 3/4 x to the 4th from 0 to 2/3, 2/3, 2 pi out front. So plugging this in and simplifying here, again, plugging in 0 is nice because those both are fx's. So really we just had to plug in 2/3 there into it, and we end up with like 208 over 405 pi. All right, again, if you want to plug that in your calculator and get a decimal, that's fine too. I'm okay with that. So I think that's what we get here. I'll check it real quick. Okay, so that is not correct. That's me doing something else and writing down the wrong answer. So I get in here, when I put in 2/3, I get 4 over 81. So I times that by 2 pi. So then I get times that by 2 pi. So then I get 8 pi over 81. That is the correct answer. There you go. Have fun with cylindrical shells. All right. Force beyond natural length using Hooke's law. So we have some type of natural length, which is just 12 centimeters, but I'm in Newton, so that means this needs to be in meters. So that's 0.12. And then I'm stretching it beyond its natural length, stretching it to 15 centimeters. So a total of 15 centimeters to here, which is 0.15 meters. So that means the length beyond natural length would be 0.03 beyond natural length. Okay, so I use Hooke's law. F of x equals k times x, where x is displacement beyond natural length, so that would be 0.03. And f of x is the force that it takes, so it takes 30 newtons in order to do that. So then I need to solve for k. So then I get k is 1,000. Okay, and then I plug it in my force equation. And now if I want to find work, I just take the integral of my force, right? So I'm going to take the integral of this force equation from these, always this a and b is beyond natural length. I want to take the integral of 1,000 k, or 1,000x, because now I'm going to move displacement. Okay, so beyond its natural length, so if I'm stretching this now from 12 to 20, so beyond its natural length, so 12 beyond its natural length would be 0, and 20 beyond its natural length would be 0.08. So now I'm doing a new stretch from here all the way to 0.20. So beyond its natural length is 0.08. Okay, so just the red part. So from here all the way is 0.2. So beyond its natural length is just 0.8. So I'm going from 0 to 0.08. Now I'm going to take the integral of that, which is 500x squared from 0 to 0.08, and we get 3.2. And because I'm in newtons and in meters, then I'm going to do joules. Okay, so 3.2 joules. All right. Okay, next one's a little bit tricky. So we'll work this one, and then I'll go ahead and make a separate video for the rest, just because I'm running out of time here. but I know some that you guys wanted to see number 7 specifically. Okay, so here is my shape that I have. So I'm going to take a cross section of that. So that's going to be cross section is a rectangle. So the volume of my cross section would be a 10 by 12 by change in y, which is just the same as dy. Okay, and then I noticed that this volume, this shape, this cross section is going to be filled with water, right? So I know that the water says right here the water weighs 62.4 pounds per cubic feet. So that means for every foot that I have of my volume, I would times that by 6.24, and that would be the weight of that cross section, which is force, right? Weight is force because weight is mass times acceleration. So that's accounted for. So then I just have to take this and times that volume, so which is 120. I just got to times that by my weight, 62.4. And so I get, let me do the math. So the weight of it is of the cross section is 74.88. Okay, so then I'm going to take that. So that is kind of my base of my force in my cross section because it's weight. I'm going to take that from the integral, and I'm taking this out from 0 to 20. Okay, now I got to times it by its displacement, right? So I can go down here to the cross section, which would just be a difference of y, right? So I'm going to times that by y. I'm just in terms of y dy. That's where that dy is coming in. So even this has a dy on it. So that has a dy right there. All right, so then I can integrate this. So I use the power rule. That would be divide that by 2. So 3744 y squared from 0 to 20. So I plug that in and I get 1,497,600. However you say that. 1,497,097.6. Sorry. And that would be in pounds and feet, so that'd be foot pounds, foot pounds, foot pounds. There you go. All right, so I'll stop the video here. Sorry about that. I will put together another video for the rest. Going through this, really this is just, I want to find the integral from my a to b, so this function. So I'm going to have to use substitution here. And then once I find that, I'm going to divide by my b minus a. Okay, so once I find that, find the definite integral of that, and then divide it by your b minus a. This problem is the same thing. I want to find the integral from my a to b of this function. So I find the integral of it, okay, the definite integral, and then I divide it by b minus a, and I'm going to take that answer and I'm going to set it equal to this function, and then I'm going to solve, oh, that's a terrible 3, and then I'm going to solve for x, okay? So I'm going to take the definite integral here, divide it by 3, and then set that equal to, set whatever that answer is, equal to 3 plus 4x squared, and then I'm going to solve for x, and you should get an x equal to just plus or minus root 3. I think that is the correct answer. And then when you solve this definite integral up here, this is, you would get x, this is equal to 3 or 15. So then I would set this equation right here equal to 15, and that's when I solve and I get square root of 3, which makes sense because that's 12. Yeah, that would be correct. Okay, so this is the correct answer of that one. So that's how you do it. This one, you should get an answer in the end of, let's see, I'm thinking this answer should be like 200.1 maybe. Maybe that's the correct answer. Okay, and then this last one, again, area under the curve, you're really just doing the area under the curve of this function. So really you just want to take the integral of that from 0 to your b to pi over pi halves of this function. So because I'm taking the sign of something other than just x, that means I'm going to do substitution. So u would equal x squared here. And then I would set that up and do it. and you should end up with this one is something like -1/2 cosine of pi squared over 4 pi squared over 4 plus a half. I think that's what you might come out with. So I'll end this video now, but I'll come back and do these problems. So yeah.